In this video, we will practice graphing sine and cosine functions with all sorts of changes to the amplitude and the period, and there will be horizontal translations, also known as phase shifts, reflections over the x-axis, all that kind of good stuff. Okay, now I am going to cheat in one small way. To make a graph, it would be helpful to have a nice straight line, so I could sketch it by hand, but why risk it? And let me go ahead and get a y-axis in here as well, just for fun. Okay, so this will be my x and my y-axis. So we've got this function, and I see that we've got here an a value. The a value is -4. That tells us that the amplitude is going to be 4. Amplitude is always positive. The negative in front is going to be a reflection over the x-axis. All right, that's what that's going to be doing. So that's good to know. So since the amplitude is going to be 4, I know that this is going to go up to 4 and down to -4. So I might as well get that going. Now, I see I have a b value sitting here. My b value is 2. The b value tells me what the period is going to be doing indirectly, because the period is always going to be 2 pi divided by the b value, which means that the period is going to be 2 pi divided by 2, which tells me that the period is going to just be pi. So great, the period is pi. So I'm going to go ahead and put pi on my graph right about here. All right, now if I go halfway, that should be pi over 2. And if I go half of that, that should be pi over 4. So in this position, I should have 3 pi over 4. Okay. Now, I see this minus pi on the end. That is going to end up giving me a phase shift, but I have to be very careful. I cannot read the phase shift right now. You have to factor this 2 out, outside of the parentheses before you can look at the phase shift. So look, right now I have 2x minus pi, but I need to bring that 2 outside of the parentheses and then see what I have. You can do that as long as you divide both of these by 2. So I'm going to have inside x minus pi over 2. This is the phase shift right here. Okay, so the phase shift is pi over 2 to the right. It's always the opposite of what you would normally think. So minus pi over 2 is actually a phase shift of pi over 2 to the right. By the way, the period we decided was pi, but I forgot to write it down, so I'll put it down now. There is no vertical translation. Imagine there was a +3 here on the end, that would be a vertical translation of up 3, but there's none. So now this should be enough information for me to sketch the graph. Okay, so first I'm going to sketch the graph without the phase shift, without moving anything to the right, pi over 2. So this is a sine function. So without the phase shift, the sine function would start at 0, and it would go up to its highest point, which in this case is at 4 because of the amplitude, and it would go down to the midline, and then would fall to its lowest point, and then back to the midline. Now, I will not connect these because it's not the final answer until I do the phase shift. But that's what it would look like without the phase shift. Now, I need to move each of these points to the right pi over 2. Now, look here. I'm noticing that pi over 2 is one of my x values. So that means that this distance right here is a distance of pi over 2. So that tells me how far I need to move this. So when I do my phase shift, I need to move all of my points this far to the right. All right, that's 2 full jumps to the right. So that's what I'm going to do, and I'm going to put my final answer in blue. So this first point, if I do a phase shift of pi over 2, it's going to land here. Now, starting from here, I can just go ahead and do the regular pattern of the sine function by going up and then back and then down and then back. I'm going to need some extra marks though, because I'm running out of space. So I'm going to put some more marks on here. Okay, and I will have to label them as well. Okay, so all of these marks are separated by pi over 4. So I really can just count in this case. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So this will be 5 pi over 4. And then this one would be 6 pi over 4. But that reduces down to 3 pi over 2. All right, so sometimes you can just count. Sometimes you can't, but we'll see that later. So now that I have all of my critical values numbered, I can put my new points down. So this is the sine function. So again, I'm going to go up and then back to the midline and down and back to the midline. So this is what the final answer should look like. All right, and there it is. I took the regular graph and I shifted it over by pi over 2. Okay, let's do problem number 10. So, I'm noticing that I've got my A value right here and I've got my B value, but I also have a phase shift trying to happen. So I know that I'm going to need to factor the B value out. I need to bring this outside of the parentheses before I can see the phase shift. So I think I'm just going to do that now before I even really get started. So look guys, right now I have 1/2 x minus pi over 4. But I need to bring that 1/2 outside of the parentheses. Okay? I can do that as long as I divide each of these by 1/2. So I need to divide pi over 4 by 1/2. But look guys, if I have pi over 4 divided by 1/2, all right, that's really, I could write that this way, pi over 4 divided by 1/2. But when you divide with fractions, you multiply by the reciprocal. So I'm really doing pi over 4 times 2 over 1. So this is 2 pi over 4. And these cancel each other out. 2 goes into 4 twice, so this makes pi over 2. So when I do this division, I get pi over 2. So I have x minus pi over 2. So this is really going to tell me my phase shift. Okay, now writing the rest of the problem around this. Okay, I have my cosine, and I have the 1/2 that's here in the front. Y equals. All right, so this is the version that I'm really going to use. So this is my A value right here. This is my B value. And this is my phase shift. Okay, right here. So what am I trying to say? The 1/2 in the front tells me that the amplitude is going to be 1/2. How about the period? The period is always 2 pi divided by the b value. So my b value is 1/2. So that's 2 pi divided by 1/2. Again, when you divide by a fraction, you multiply by the reciprocal. So 2 pi divided by 1/2 is really 2 pi times 2. So the period is going to be 4 pi. Now the phase shift, I can only read the phase shift after I have factored out the 1/2. So that's why the phase shift is pi over 2. Okay, notice it is not pi over 4, it is pi over 2. And it's the opposite of what you would think. With a negative sign here, that means this is pi over 2 to the right. There is no vertical translation because there is no k value that would be in this position. Okay, and really, okay, in fact, this is, I call this my A, this is my B. This is called the H value. And the vertical translations are called K values. All right, but that's my H. But the H is the phase shift. Okay, that is plenty of information. So now I should be able to sketch the graph. So as I begin the graph, the first thing I look at is the period. The period is 4 pi in this case. So I'm going to come way over here somewhere and put my 4 pi down. Now if I go half of that distance, of course that will be 2 pi. Half again, that will be just pi. And in the third position, that will be 3 pi. Next, I look to see if there's any vertical translation, and I remember there was no number on the end, and I should go ahead and write none right here, but there is no vertical shift. That means the x-axis is going to be the midline, so I really can go ahead and start doing the graph now. Time to pay attention to the amplitude. Since this is the midline, that makes it really easy to label for the amplitude. Even though this is 1/2, I don't really need to go between the lines. I can just go ahead and call this 1/2. And I can come down here and call this -1/2 if I want to. Okay, so the cosine function, if there was no phase shift, would start right here. Cosine starts up high, and then it falls to the midline, and then it goes down to its lowest point, and then back to the midline, and then it ends at its high. So that's what the function would look like if there was no phase shift. But there is a phase shift. Everything has to shift pi over 2 to the right. So pi over 2. It would be helpful for me to see where pi over 2 is in this picture if I can. Well, pi over 2 is half of pi. So here's pi right here. So it makes sense that pi over 2 would be right here in the middle. Alright, so this is pi over 2 right here. So this tells me how far over I have to shift each point. And I see it happens to be exactly half of a space. So it would be helpful if I just go ahead and put a mark halfway between each of these, because in every case I'm moving half a space over. Okay, and including one more over here. I'm going to have to label all of these. Because it's right in the middle, I could just count to get my answers. So that's what I like to do. So I could think of this as 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and 9 pi over 2. For me, that's the easiest thing to do. Now, if you did not like the counting thing, or if there was a case where you weren't sure how to count, then you could look at it as addition. So for example, say if I wanted to find this using another method, well, I'm shifting pi over 2 to the right of pi. So I could think of it as adding pi over 2 to pi. Alright, so what's pi plus pi over 2? Well, I would need like denominators, right? So I would multiply this by 2, and that would give me 2 pi over 2 plus 1 pi over 2, which is 3 pi over 2. And so that's another way I could have gotten 3 pi over 2. Now for me, the counting thing that I did at first is much faster. So you decide how you want to do that. But now we are ready to go ahead and draw the actual graph. If I take this very first point and shift it over pi over 2, you keep an eye on the green mark here, this is where it would land. So after that, I really could just do the cosine pattern, or I could look at each point and imagine shifting each point over one at a time. Alright, so these blue points now represent the actual graph. And that's it. Let's do one more on this video. So I've got my a value here of -2. That tells me that the amplitude is going to be 2. Amplitude is always positive. This negative sign in the front will be a reflection over the x-axis. Alright, so that's what this negative sign is doing. So watch out for that later. What about the period? I've got the b value right here. My b value is 1/2. So the b value will indirectly give us the period, because the period is always 2 pi divided by the b value. So in this case, that means the period is 2 pi divided by 1/2. And when you divide something by a fraction, that's the same thing as multiplying by the reciprocal. So the period is going to be 4 pi, just like the last problem. So the period will be 4 pi. Now as far as a phase shift, we would have a phase shift if there was an h value, like x plus h. But there is no h value, so there is no phase shift. So I'll just say none. Also, there is no k value. A k value would happen right on the end of this thing, like if I had plus k. So there's none of that either. So for vertical translation, I will also say none. So we are ready to do this graph, people. Why didn't anybody tell me that I wrote non here when I was supposed to be writing none? Somebody should have spoken up. That's on y'all. Now, let's get back to this graph. Let's see. The period. You really want to start with the period. So since the period is 4 pi, I'm going to come way over here and put 4 pi on the graph. So if I go halfway, that will be 2 pi. Halfway again, that will just be pi. And in the third position, that will be 3 pi. Now look at the amplitude, which is 2. Since there is no vertical translation, the x-axis is still the midline. So I can just label the amplitude by going up 2 and down 2. So that keeps it pretty simple. Now this is a cosine function. So normally the cosine function would start off high like this, and it would drift on down to the midline, and then it would fall to its lowest point, and then back to the midline, and then back to its highest point. So this is what the cosine function would normally look like. In fact, I'm just going to draw it because I'll just delete it in a second. Alright, but the only thing that's going to change that right now is this negative sign in the front. We need a reflection over the x-axis, so this whole thing needs to turn upside down. That means instead of starting up high, we're actually going to start down low and then go up from there. So we will put the first point here, and then we will drift to the midline, and then we'll go to the highest point, and then back to the midline, and then the lowest point. So this is what the actual graph will look like. Alright, and that is it for number 11. I think that one was relatively straightforward. And that's going to do it for this video. I will do the remaining few problems on the next video.